Hello and welcome to Science, where we study with a cup of tea so you don't fall asleep. So go and grab that drink while I go and grab the science. The first principle of differentiation, which states, as we all know, that dy upon dx is equal to function of x plus h minus function of x whole divided by h when the limit is h approaches 0. So we all know that, but do you know why is differentiation? Well, let me tell you why. You see, average velocity as defined as delta s by delta t, that is change in displacement divided by change in time. What about instantaneous velocity? What if I want the velocity at an exact moment in time? Let's find that out with the help of an example. Here we have to find the velocity of an object at t is equal to 3 seconds. The object starts from rest, and we are already given that displacement changes with respect to time as t square plus 1. This sounds very complicated, but it's very easy. So, if we just put values of t one after another in this function right here, we get the displacement at specific times. So, what if we take the displacement between t is equal to 0 and t is equal to 3? Well, at t is equal to 0, s is equal to 1. At t is equal to 3, s is equal to 10. Using this formula, we get 10 minus 1 divided by 3 is equal to average velocity. So 9 by 3 would be 3. So our average velocity is 3. So that should be the instantaneous velocity, right? Wrong. So let's try something else. What if we take the velocity, the average velocity between t is equal to 2 seconds and t is equal to 3 seconds? So using this function again, we would get here s is equal to 5 and here it would be 10 again. So we get 10 minus 5 average velocity is equal to 10 minus 5 divided by 1 because the change in time was 1 second. So this time our average velocity is 5 meters per second. That's weird. It was 3 just now. Why is it 5? Does that mean the value is not constant here? Exactly. So let's try something else. What if we take the average velocity between t is equal to 2.9 seconds and t is equal to 3 seconds. Now the average velocity here would be 0.1 in the denominator, while we have 9 plus 1 minus 2.9 square, 8.41, and that plus 1, which would give us 5 uh, 0.59 divided by 0.1, which is the same as 5.9 meter per second. So the value increased significantly between what was the time here? Yeah, between 0 to 3 to 2 to 3, and then it's changed slightly between 2.9 to 3. That means that we are getting closer to the instantaneous velocity. What exactly is differentiation? Well, as we saw here, as time decreases, we get closer to the instantaneous value. So, how would we get the instantaneous value? What if the time was 0? But well, we can't use that. So, how would we do that? That's why differentiation exists. We created this function so we could find the instantaneous velocity and acceleration and such related terms using differentiation. So when we say function of x plus h minus function of x divided by h in the limit h approaches 0, what did we do here? We decreased the time. This is exactly the same formula, but here h, which is our delta t, is moving closer and closer to 0. At one point, it will be 0 and it's giving us the exact value. So, what if we put our function in here? So, we would get x plus h whole square plus 1 minus x square minus 1 whole divided by h, which would be x square plus 2xh plus h square minus x square. The 1 cancel out, the x squares cancel out, and we can divide by h. That would give us 2x plus h. But wait, isn't h basically 0? So the answer should be just 2x. And that is it. When we put our values into this here, when we put the value of time here, that's what we get. And actually, our x here was t. Usually you define it in the form of dy by dx. You will define y as a function of x. Right now what we did was dx by dt, where we defined x as a function of t and we divided it by time, which was significantly close to 0. So we could just call it 0 in the end. Now this does not give us approximate answers. It is the correct answer and it has been tried and tested. So if we put our value of 3 here, we would get 6, and that was the answer. So did you understand what we did here? I'll just go over it once. We used the average velocity formula to get closer and closer to the instantaneous value. And then we came across differentiation, which is the same thing. It's the same formula that we use for average velocity, but h is very close to 0, like 0.0000 and so on 1. That is h, but it gives the exact value. Why? Well, because h is basically 0, but We can't divide by 0, but h is approaching 0, it's not 0, and somehow that works. There is a graphical proof for it. If I say this here is our displacement and this here is our time, and I make a random graph like this, what we are doing here is we are moving a chord. This could be our 3 and this could be 1. So from here we are just finding the slope. But in the example above, we were just changing this chord into a smaller chord, till at one point it was a tangent. It only touched the curve at a single point. That's what differentiation did. And with that, we simply have to find the slope, because when we add this part and we call it h, this whole side is our delta t plus h, and this side would be function of x plus h, while this part is function of x, and while we subtract that on the top, we do this at the bottom by subtracting delta t from this, and then we are basically finding tan theta. So that would be function of x plus h minus function of x divided by delta t plus h minus delta t, and we get h in the denominator. Actually, this would be t, function of t plus h and function of t, because we have described our displacement in terms of time.